So we're going to start today with a little review. So hopefully you recognize this as a dissociation reaction. So I'd like you to write the equilibrium expression for this reaction. And hopefully you'll get to KEQ equals concentration of Ag plus times the concentration of Cl minus. Now, why don't I include the AgCl? Well, it's a pure solid, and pure solids are never included in equilibrium expressions. Now, let's think about what this means for a second, okay? I have a compound here that is not very soluble. Silver chloride is not a soluble compound, okay? So if I put silver chloride in solution, I'm going to form some sort of, I'm going to form ions, and then I'm going to establish an equilibrium where ions are reforming solid at the same rate that the solid is breaking apart into the ions. Okay? Which means that we're assuming that this solution is either saturated, supersaturated, or unsaturated. So why don't you pause and think about which one I'm talking about here. I am, of course, talking about this being a saturated solution. Brilliant. All right. Now, this equilibrium constant here will tell me to what extent a solid will dissolve in or form ions when it comes in contact with water, which means that this equilibrium constant is really related to the solubility of a compound. And as such, it's given a special K. I know, they're all special, right? But this one's another special K, another K. Oh my goodness, more Ks. It's capital K, SP. Where SP, that is the worst arrow I have ever drawn. That SP stands for solubility product. All right, and today we're going to be talking about solubility products, all right? And how do we find them? How do we calculate them? How do we use them? So, how do we find solubility products? Well, remember that the solubility product is only for those salts that have low solubility. So if we come to our solubility rules, all right, we're looking for things that are insoluble, like metallic oxides are insoluble. Because these soluble things form too many ions, all right? They don't readily make equilibrium systems. They kind of go to products, all right? So we're talking about, in general, things on the solubility rules that are listed as insoluble or only slightly soluble, all right? Make sure that the reaction is at equilibrium, meaning make sure that we have a saturated solution. Next, chemical equations should always be written so the solid salt is the reactant and ions are the precipitate. All right, solid salt is the reactant and the ions are the products. Sorry, no precipitate in there. Products. Write a solubility product expression. There you go. So ion concentration products. There we go. Concentrations of solids or pure liquids are not taken into account because they don't get put in equilibrium expressions. And this is an equilibrium system. This is all based, all of this stuff should be based, should be similar to equilibrium, how you write equilibrium expressions. Okay? A couple of key things here. This is one. Remember that KSP values depend on temperature. Remember, solubility depends on temperature, and since solubility is basically KSP, KSP is a way of reporting solubility, that's also going to depend on temperature. All right, and then the last thing here, you're welcome, calculations of KSP ordinarily should be limited to 2 significant figures. All right, so limit us to 2 significant figures, please. So at this point, I'd just like to do a bunch of sample problems, all right? You know, I would look at what I do for each of the following sample problems. If you're getting it, you can kind of speed through what I'm doing. If not, stop, go slowly, take notes. Make sure that you're really ready to go. All right?